Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to continue my series on doing first-person graphics. Last video, we finished making the graphics, and so now we're ready to display them in the program. As you can see, I am displaying them, and as you can also see, there's a consistent environment created. When I move, when I turn, everything looks as it should. It's not a very interesting environment so far because we've only got open space and walls, and it's quite restricted because the algorithm we're using to decide where the walls go isn't very good and doesn't ensure that you have sort of access to the whole area. But those are things that we'll fix as we go forward. For now, let's have a look at how the code works to display this, what seems like a picture, but is actually several pictures. If I select it, you can sort of see that it's actually several different pictures displayed next to each other, which makes sense, of course, because we were making little partial pictures. Okay, so let's get into the code. So we haven't looked at the code for a few videos because we've been in GIMP looking at creating graphics. So I'll just refresh your memory on what's happening here. We have X and Y are the size of the environment. The main variables we're going to be using today are E, which is an array which stores the state of squares near the player. So that will be different each move. And specifically, $E, $A, $B, it's a two-dimensional array, of course it needs to be. $E, $A, $B is the square that is B squares forward and A squares to the right of the player. And of course, what is forward and what is right and left and behind change depending on which direction the character is facing, which is stored in the variable D, with 1 being north, 2 being west, 3 being south, and 4 being east. We also have M, which is another two-dimensional array, which is the state of the environment. M does not change. E will change every movement because it's what's near the player and in front of the player, whereas M is the sort of objective state of the environment. And so, for example, M23 would be the square that is in the second column from the left, hence the 2, and the third row from the bottom, hence the 3. If we counted the bottom as being south and the top as being north. So M is the environment, which doesn't change once it's generated. E is the squares nearby the player, which change every time the player moves or turns. And we have these variables that tell us what pictures to display. Now, initially, and when we were saving the pictures, I called them things like R and L and C for right, left, and center. But then, because there's up to 7 bands, I needed to start saying things like center, center, and center left, and left center. And so it got a bit confusing, and I decided to do it a different way. And instead, I've called the pictures F, G, H, I, J, K, and L, where F is the one on the left, and then G, and then H, I, J, K, and L. Why F to L? Why not A to whatever that would be? A, B, C, D, E, A to G? Well, because I had already used D and E for the direction and the nearby environment. So that was just a string of letters that were free. And you notice that there's F $F, $G, and then there's $HIJ. That's because we might have a single picture that covers the center, or we might have three pictures which are covered by $H, $I, and $J. So I'll just give you a quick look at the artwork. So we have things stored, instead of having it as L1, etc., we have F1, F2, F3, F4, and those are all different options for the leftmost one. Then G1, G2, and G3. We have this picture HIJ, and if that's displayed if we're using a single picture in the center, which happens if there's a wall directly in front of the player. Otherwise, we use one of H 1 to 4, one of I 1 to 5, and one of J 1 to 4. And then we have K and L, which are the equivalents of, L is the equivalent of F, and K is the equivalent of G, but they're on the other side. So we use those names for both the variables and the pictures, which makes it a bit easier to remember. All right, so let's get into the code. The main bit of the code that we're going to need to look at is display today. We've already talked about how we generate it, not very well. We're going to have to come up with a better system than the one we have. And then we assign the position randomly and have the player start by facing north. Now I've already dealt with the buttons, how the buttons work, how you turn and how you move forward. So I won't go through those in detail, but instead I'll just go through how E is filled in, and then how we turn, how we go from, once we've stored things in E, we then look at various slots in E, and based on what we find there, we assign values to F, G, etc. All right, so we have two for loops. For Z equals -1, and it goes up to 1, and V starts at 0 and goes to 2. So Z is how many squares to the right of the player, and V is how many squares forward. So we're going from -1 squares right, which is to say 1 square left, and then we're going up to between 0 and 2 squares forward. In other words, from beside the player to 2 squares ahead. One consequence of this is that we're going to store a value in E00, which is where the player is standing, and that's always 0. So there's no need to ever look in that slot. But if we've got these for loops, well, Z is going to be 0 and V is going to be 0 at one point. And I found it easier to let's just do that rather than have a special exception. I could have done something like, if Z does not equal 0 or V does not equal 0, then do all this stuff. But I decided it was just as easy to just do it and not worry about a slight redundancy. Okay, so because Z is how far to the right and V is how far forward, they're not a set direction. What direction is right and what direction is forward will depend on what direction the character is facing. And that's what we do in this if, else if, else if, else if, /if code here. So we have if D equals 1, we do what happens when it's facing north. If D equals 2, we do it's west. If D equals 3, we do south, and otherwise it's east, because D is only ever 1, 2, 3, or 4. So north is the easiest one to conceptualize, probably. We're going to find values for x1 and y1, and they'll just be what square in the array M do we need to look at. And sorry, there's one more thing I didn't remind you of that I should have, and that is that x2 and y2 are the character's position. All right, so x is the size, x and y are the size of the environment, x2 and y2 is the character's position, and x1 and y1 are going to be the position in the M array that we need to look at. So north is easiest to conceptualize, as I said. We set x1 being equal to x2 plus z. So the character's current x position plus whatever z is. y1 is y2, i.e. the character's current y position, plus however many squares forward. If we're facing south, it's the opposite. x1 is x2 minus z, because each square to the right is west, which is to say a reduction in the x value. And similarly, if you're facing north, y1 equals y2 plus v. If you're facing south, y1 equals y2 minus v, because forward means south, which is to say a reduction in the y value. West, z and v sort of swap places compared to north and south. So x1 is x2 minus v, and y1 is y2 plus z. And then if you're facing east, x1 is x2 plus v instead of minus v, and y1 is y2 minus z instead of plus z. So imagine you're facing west. Well, forward to you is west, which is to say a reduction in the x value. So that's why that is as it is. And your right is north. So how many squares to the right will increase y1? And then if you're facing east, it's the opposite. So having done whichever one of those is relevant, we set E, Z, V equal to M, x1, y1. So we found x1 and y1. We look at M, x1, y1, and we put that in the relevant slot of E, and then we close off the for loop. So we do that for every value within these two ranges. Then we're going to set these variables f, g, and h, etc. in order. And it's very, very, very similar to the guide artwork that I made. I'll bring that up again. Where's my picture? There it is. Open that. Go to Let's Make a Game. First person movement. Artwork. Actually, I'll open it in Chrome just because Chrome's already open. Okay. So you may recall we have this little picture here, which has FF and F and FR, etc. Those are the names we use within GIMP. Now instead we'll be looking at E. So like L will be E minus 1, 0, because it's minus 1 squares to the right and 0 squares forward. Similarly, F would be E 0, 1, because it's 0 squares to the left and 1 square forward, and so on. All right, so we look at how left is going to work, and the way it works is if there's a wall in L, in other words, if that slot of E is 1, if E minus 1, 0 equals 1, then we're going to use what was L1 and is now F1. If that's not true, but this one is a wall, so that would be minus 1, 1, then we're going to use what was L2 and is now F2. If neither of those are true, but this one is a wall, so minus 1, 2, then we use the third option, and if none of those things are true, we use the fourth option. So that's quite easy to turn into code. Let's go back to the code. And we simply say, if E minus 1, 0 is equal to 1, then set F equals 1. If else if E minus 1, 1 is equal to 1, then we set F equal to 2. Else if E minus 1, 2 is set to 1, then set F equals 3. And if none of those are the case, set F equals 4. Now, because this is basically symmetrical, the way that L works is going to be basically the same as the way that F works, except that instead of -1, it's going to be 1. In other words, it'll be looking at squares to the right. So if E10 equals 1, then we set L equal to 1. If E11 equals 1, we set L equal to 2. If E12 equals 1, we set L equal to 3, and then otherwise we set L equal to 4. Similarly, back to the guide, the left centre line, what we were calling LC, and what we're now calling G, it's another if-else if. If E minus 1, 0 equals 1, then we choose number 1. But note that there's lots of options where we choose option 1. It's not 1, 2, 3, 4. It's 1, 1, 1, 2, 3. So if E minus 1, 0 equals 1, then choose number 1. But if E minus 1, 1 is equal to 1, then also choose 1. And if E 0, 1 is equal to 1, then choose option 1. If none of those things are true, but E minus 1, 2 is equal to 1, then choose 2. And if none of those things are true, choose 3. And again, that's very easy to turn into code. And this will be variable G. If E minus 1, 0 is equal to 1, or E minus 1, 1 is equal to 1, or E 0, 1 is equal to 1, then set G equals 1. Else if E minus 1, 2 is equal to 1, set G equals 2, else set G equals 3. And again, because it's symmetrical, K will work basically the same as G does. So if we go down to K, we see 1, 0, 1, 1, and 0, 1 instead of where is it? There it is. Instead of minus 1, 0, minus 1, 1, and 0, 1. So it's still using 0, 1 because flipping that left to right doesn't change the square. So if those squares are any of those squares are equal to 1, set K equal to 1. Otherwise, if E12 is equal to 1, set K equal to 2. Otherwise, set K equals 3. Now, Hij is really the only part where it gets a bit complicated because we have the possibility of 1 picture or 3 pictures. So we say if E01 is equal to 1, well, that's the block or the square directly in front of the player. If that's true, then we set Hij equal to 1. So Hij is a separate variable to Hi and j. Otherwise, we set Hij equal to 0, and then we need to do Hi and j separately. And that's going to come off so the equivalent of setting Hij to 1 is this. And then if that's not true, we use center left, center center, and of course center right is the flipped version of center left. So center left, which is now H, $H, is if E minus 1, 1 is equal to 1, then we choose option 1. Else if E minus 1, 2 is equal to 1, then we choose option 2. Else if E02 is equal to 1, then we choose option 3. Else we choose option 4. And once again, when we go into the code, we see that that's translated pretty directly. If E minus 1, 1 is equal to 1, set H equal 1. Else if E minus 1, 2 equals 1, set H equal 2. Else if E02 equals 1, set H equals 3. Otherwise, set H equals 4. And we will see that J works the same, except that it's flipped. So if E11 is equal to 1, set J equals 1. If E12 equals 1, set J equals 2. Else if E02 equals 1, set J equals 3. So this one's the same because flipping that left to right doesn't change anything. Else set J equals 4. So we're using E11 and E12 instead of E minus 1, 1 and E minus 1, 2. And then center center, as we used to call it, and now we're calling it I. The way that works is if E02 is equal to 1, then we choose option 1. Otherwise, we choose whichever of these options is correct. So if E minus 1, 2 and E 1, 2 are both equal to 1, we choose 3. If minus 1, 2 is equal to 0, but 1, 2 is equal to 1, we're going to choose 3. If minus 1, 2 is equal to 1 and 1, 2 is equal to 0, then we choose 4. And if not, they're both equal to 0, we choose 5. And again, very easy to turn into code. So we say if E02 equals 1, set I equals 1. Else if E minus 1, 2 equals 1. And then we have an else if within that, because we're dealing with two. In everything else, every block has a different, as it were, a different priority. Like in this one, we say if this is 1, then choose 1, regardless of anything else. And only if this is equal to 0 do we look at this one, and only if that's equal to 0 do we look at that one. Well, in this one, in center, or I, $I, we have these two blocks are a sort of equal priority. So looking back at the code, if E minus 1, 2 is equal to 1, then I is going to be equal to either 2 or 4. So in other words, if that one is equal to 1, we're going to be using either 2 or 4, depending on the state of this block. And then the same thing is true if it equals 0. If that one equals 0, then we will choose either 3 or 5, depending on the state of that one. So to get back to the code, which is here. So 3 is the one where the other one is equal to 1. We can see that from the guide, and 5 is the one where it too is equal to 0. And then we get to ones we've already done, because we've got J and K and L, and as I've already shown you, they are the mirror images of previous ones. So we have all these variables. We have F, G, Hij, which is 1, and then H, I, and J, and K and L. And it's very simple to create the code to print those, because if F is equal to 2, we want to print F2, and if I is equal to 3, we want to print I3, and so on. So we have, but we can't do the images, we can't print the images directly. We have to create a long string and then print that string within an array. Well, in this case, it's within an array. We have to print that string all in one hit, because if we print them one at a time, it'll make little gaps between the pictures, and that is not what we want. There's another way of printing all the pictures together. I've gone through that. We could have a div with a set width, but I just find this easier. So we start with Z being equal to, and this is our image. This is the way the image command works. We have square bracket, img, square bracket, whatever files it's in. Well, all of our art is in art slash, well, it's in the art directory. And then in this case, we go F, and let's say F is 1. Well, then we print 1.png, and then we have 2 end brackets. So we're going to have a series of image commands that are in a similar format to this one. And then we add to Z the command for G. Now, if Hij equals 1, we don't have Hij1. We just have a picture called Hij. So we just set Z equals Z plus this string here, art/hij.png. Otherwise, we do 3 separate things where we add H, whatever H is, I, whatever I is, and J, whatever J is. And then we add whatever K we want and whatever L we want. Then we have a table. And the reason we have a table, let's get back to the picture. The reason we have a table is so that all these buttons and this are in the right place. So we have a table, we have an empty cell, we have a cell with all the pictures, We have an empty cell. We start a new row. We have a cell with the button. We have a cell with the turn left button, a cell with the forward button, a cell with the right button. We start another row. We have an empty cell. We have the text of what direction you're facing. In a proper game, this would probably be a graphic with a little compass or something like that. And then we have another empty cell. So we have TD/TD. That's TD/TD is how we have an empty cell. TR is how we start another row. Then we have TDZ, which is all this text we've been creating up here. /TD, another empty cell. End the row, start a new row. TD, we have the button to turn counterclockwise, which I've already dealt with the code for that in an earlier video. /TD, then we have a cell with the button to move forward, which I've already dealt with. Then we have a cell with the button to turn clockwise. Then we end the row, have another row, an empty cell, a cell which we have aligned to the center so that the forward button is there and not sort of over here, which is where it would be by default. It'd be right at the left of the cell, which is not what we want. And then we just say facing. This is quite a clumsy way to do it, to go if D equals 1, then print north, and D equals 2, print west. What I should probably do is have an array and then just say print D, print that array, and then the slot be equal to $D. But I've done it in a sort of slightly primitive way. But if we have other places where we're going to print the direction, then we'll probably change it to an array. But for now, we've just got an if, else if, else. And then we have yet another empty cell. Then we finish off the row and finish off the table. And that is how that works. So now we have an environment that we can move around. And going forward, we're going to start making the environment a better environment, a more interesting environment. And the first thing we're going to do with that, I think, probably, is look at how to generate a better environment, as in how to generate an environment which is large and which isn't going to cause delays or errors, which quite a lot of algorithms I've seen online actually do cause delays or errors in Twine, and that allows us doesn't have the possibility that we'll be stuck in we'll get unlucky and be stuck in a little bit and only be able to sort of move back and forward across a few squares. We want to, of course, be able to access sort of most of the environment. So that's what we'll be doing in the future. But for now, I hope this was useful or interesting to at least some of you, and I hope you will tune in next time.